Alright, so today what we're going to be doing is we're going to be going over some key terms, okay, that are going to help us going forward with all of our geometry that we're going to be doing this semester, okay. I know in the beginning of the semester we started with a little bit of statistics, but the rest of the semester is mostly geometry, so we want to get some key terminology written down to help us going forward, okay? So, the first key term, point, okay? So, we're going to go ahead and write down the definition of a point. So, the geometric definition is this is a location in space. It has no size, width, or thickness. Okay, so it's just a place in space, basically. Okay, so there's an example, a point. Okay, normally we label a point with an uppercase letter, capital letter. Okay, so next we're going to go to line. Okay, it is a collection of points that continue in both directions infinitely. Okay, so a line is made up of many, 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 many points. Okay, so a line looks something like this. Usually it has arrows on the end because it represents that it's going in both directions forever and ever. Okay. We typically label a line with a lowercase scripted letter, like a lowercase cursive letter. So for example, I could call this line B, and I would use like a lowercase scripted letter to write that. Okay, another way that I can name a line is by 2 points on the line. Okay, so if I said point C was over here and point D was over here on this line, I could also call this line CD. So I could call the line by its lowercase scripted letter, or I could call it by either of the points on the line. Okay? Okay, so a plane. What is a plane? It's a flat surface in space with no thickness. Okay, So if I could equate a plane to something in the room, it would be like, for example, like the top of your desk, or the wall, or this projector screen. Okay, it's a flat surface, okay, in space. Now, when we talk about a plane, it has no thickness, and it continues forever in all directions. Okay, so if I think about this screen is only a portion of a plane, okay, because it doesn't actually continue forever, right? But if you were to extend this projector screen like this to the right and to the left and up and down, and it could just spread out forever and ever and ever, that's what we call a plane, a geometric plane, okay? All right, so typically when you see planes, they're kind of drawn like with a slant. They almost kind of look like they're drawn like a parallelogram or something like that, okay? And generally, if it's a plane, it's going to be labeled with an uppercase scripted letter. So, for example, it could be labeled with like an uppercase scripted letter, okay? Or we can also label it by 3 points in the plane. Okay, so say I had point X, Y, and Z in this plane. I could also call that plane XYZ. I could call it by 3 points, or I could call it by the uppercase scripted letter. That's how I could identify it, okay? Does any of this sound familiar to you guys from last year? Like when you did geometry at the end of the year? Some of it, a little bit? Okay. All right. So next one, line segment. This is a portion of a line with 2 endpoints. Okay? So a regular line will have arrows to show that it's continuing forever and ever. A line segment is going to have 2 endpoints. Okay? Those 2 endpoints are typically going to be labeled for you with capital letters because they are points. Okay, so I could call this line segment DE. Okay, so we name a line segment by its 2 endpoints. Okay, now, does anyone know the difference between a line segment and an array? Carly? Yeah, very good. Okay, so array is it's a portion of a line with 1 endpoint okay, so it's a portion of a line that only has 1 endpoint, right? So what array looks like is one side is continuing forever and ever, and the other side there's an endpoint. Okay. Now, typically how we name array is we put another point that the ray is passing through, and we could call this, for example, ray G H or something like that. So we're still naming the ray by its 2 points on the ray, but we're always using the endpoint as one of the points. Okay, so for example, I could call this one Ray GH or something like that. Now, there's like a shorthand notation that looks like this, where you could call it also, when you're writing its name, Ray GH. So if I were like naming this one, I'd name it segment DE. Okay? And if I were naming this line over here, I would have a different kind of notation with arrows, line CD. So does that make sense, the difference in the notation between what I'm labeling? See how the ray looks like the ray, the segment looks like the segment, and the line has two little arrows because it looks like the line. Does that make sense? So when you're reading like geometry problems and it's giving you a word problem or something, you need to understand the difference between these three markings. That one is talking about a line that's continuing forever, one is talking about a segment, and one is talking about a ray. Okay, they're three different things. Does that make sense to you guys? Okay. All right. So now let's continue on in a couple more definitions. So collinear. Okay. What does this word co mean? Like if I asked you, what's a co-worker? What is that? What's a co-worker? Somebody you work with, right? Okay, you work together, right? In the same workplace. Okay. Collinear, you think of linear meaning from a line. This is 2 points that are on the same line, okay? So this is describing 2 points on the same line. Okay, and it can actually be 2 or more points. I should throw that in, because sometimes we can have 3 points or 4 points or 5 points that are all collinear. Does that make sense? So let me give you an example of this. Okay, so points A, B, and C are all collinear. Okay, is D collinear with those 3 points? Does D share a line with those 3 points? No. Does that make sense? So these points are collinear. This point is not collinear with the 3 of them. Now, if I were to create a line, could D be collinear with A? If I drew a line here, could it be collinear with A? Could it be collinear with B? Could it be collinear with C? Okay, but can it be collinear with all 3 of them at the same time? No, right? Does that make sense to you guys, what I'm saying there? Okay. All right, let's take a look at coplanar. Okay, this is 3 or more points on the same what? What do you think we're talking about here? Plane, right? All right. So I'm going to draw something, and I want for you guys to try really hard to draw this. Okay, I know it's kind of hard to see, but what that's supposed to look like is, if maybe I can do that to kind of help you guys a little bit. It's supposed to be like 2 planes crossing each other, like if you think of 2 papers, like one cutting through the other. Does that make sense? Okay, so let's say I have this point, let's call it H, this point, let's call it R, this point over here is Z, and then I have a point up here, which is, I'm going to call Y. Okay. Which points are collinear? Or sorry, coplanar. Which points are coplanar? Which one's not coplanar with the other three? Y, because it's on that vertical plane. Does that make sense? So we would say H, R, and Z are coplanar, right? They're all in the same plane. Y is not coplanar with those other ones. Does that make sense there? Okay. All right, now let's talk about midpoint. Okay, midpoint is the point that basically cuts a line segment in half. You guys kind of learned about midpoint already, right? But it's the exact middle of the line segment. So if you have a line segment here, this is your midpoint, right? Let's say this is line segment A and line segment B. The midpoint's going to cut that segment in half. Now, to show that this is the exact midpoint, we put marks on each part of the line segment. Do you guys know what these little tick marks mean? It means that this segment and this segment are congruent, that these two parts of the line are the same exact size. Does that make sense? Have you guys seen these marks before? Sometimes you see like double tick marks or triple tick marks. Have you guys seen those before? Okay. All right. Okay, let's talk about a segment bisector. This is a line ray. It could also be a line segment or other figure. Sometimes it could be a plane, sometimes it could be a point, okay, that cuts a segment in half. Okay, so let's say you have this line segment, let's call it AB, and here's the exact middle right here, and you have this, I don't know, let's use a ray. You have this ray, CD, but these two sides are congruent. That ray is a segment bisector. Okay, so segment bisector is the object or the thing that is cutting the line segment in half. Okay, so it's the one that's doing the cutting. This thing is intersecting the line and cutting it in half, or marking the midpoint. Does that make sense on that one? Okay, now these two we've gone over before, right? We've gone over the midpoint formula, we've gone over the distance formula. Right now I want you guys to write down what you remember about those. Okay, if you need to, talk to your neighbor about these two, but I want you guys to go ahead and write those down right now, what you recall. Okay, so what do you guys remember the midpoint formula is? Add your x's, right? And then divide by 2. And then what? Add your y's. And then divide by 2. Okay? All right. For an example, we're not going to do an example today because we have a lot of examples already in our notes on page 6. So you're just going to write C notes page 6. Okay? All right, now what about the distance formula? What's that formula? x2 minus x1 squared plus y2 minus y1 squared. Okay? And that's also in our notes on page 6. So we're going to write C notes on page 6. Okay, now last, you guys learned about Pythagorean theorem, right? What's the formula for Pythagorean theorem? Equals c squared. What kind of triangle does this work with? Only with right triangles with 90-degree angle, right? At least one 90-degree angle. And the side across from the 90-degree angle is the hypotenuse, which is the c, right? Okay, for examples, you're going to write C notes on page what? Page 7. Okay. All right, once you got this front part filled out, go ahead and flip over. Okay. Are we ready? Okay. All right, so we're going to do a couple examples together. Okay, we may not finish all of these today, but we'll at least get through some of them. Okay, so let's take a look at examples 1 through 3 in this box. Okay, we've got a plane here. I know it's a plane by the way it's drawn. It also has an uppercase scripted letter N, which is telling me I can call it plane N. That's its name. Okay, I have some lines that are inside, they're contained in this plane, right? Okay, I have another line. Can you guys see this one? It's cutting through vertically down through the top of the plane. Do you guys see that? Okay, so it says name a line that is not contained in plane N. So which line is not completely contained in plane N? It's just going through it, but it's not actually in it. Like, it's not on the plane, the whole line. That would be this one, right? So how could I name this line? What's one way to name a line? By 2 points on the line, right? So what could I name it? Could I name it line AB? Could I name it AE? Could I also name it BE? Yeah, any of those names would be fine. Pick the one you like the best. Okay, I'm going to just name it line AE. But you could call it line AB or line BE. Does that make sense? Okay. Okay. Name a plane that contains point B. Okay. So look at where point B is. This is the plane that is containing it. What is the name of this plane? Plane what? What's its uppercase scripted letter? N. So plane N. Does that make sense? Now, another way to name a plane is to name the plane by 3 points on the plane. So you could have also called this plane C, B, D, right? Those are 3 points that are in that plane. So there's several different ways you can name the plane, just like there were several different ways you could have named the line. Does that make sense? Okay, next, name 3 collinear points. So what are your 3 collinear points? They have to be on the same, remember what collinear means. What does collinear mean? On the same line. So what 3 points are on the same line? A, B, E. So point A, point B, point E. Does that make sense there? Okay. Okay, we're going to skip this one right now. Okay, and we're going to do a little bit of drawing. Okay, so let's go to this one. Okay, it says draw and label a figure for each relationship. Okay, so number 7 in this box, planes M and N intersect in line HJ. Okay, so let's try to draw 2 planes that intersect. Okay, if you want to do this in pencil, that's fine. Okay, so I'm going to draw one plane. Here's one plane. And to make my other plane intersect, it's going to cross it, right? So maybe what I'll do is I'll kind of draw something like that. Now, the place that they intersect is going to be a line, right? So this place right here This is the line where they're intersecting. And what did it tell me to label that line? HJ. So I'm going to put points on that line. I'm going to call it line HJ. And now what did it tell me the names of my planes were? M, so a scripted uppercase M on one of them, and a scripted uppercase N on the other one. Okay, does that make sense what we've drawn there? Okay. Okay, we're going to do one more. We're going to do number 9. Okay, let's take a look at number 9. It says line T contains point H, and line T does not lie in plane M or plane N. Okay, so here's what I'm going to draw. I'm going to draw plane M, I'm going to draw plane N, and then I want to draw a line containing a point that's not in that plane. Okay, so let's draw our two planes. Here's one. Here's the other. That's where they're crossing, right? Okay, let's call this one M and this one N. Okay, now this is just like its own situation. It's different than what we did before, so we don't need to worry about what we did before. It says line T contains point H, and line T does not lie in plane M or plane N. Okay, so I need to draw a line that's not going to lie in either of these. Okay, so maybe I draw a line that's like just randomly like up here, it's going through space, and it's not lying in either of these. Does that make sense? And it says we're going to call it line T, and it contains a point called H. Okay? So if I draw this line's going this way, this plane's going this way, that plane's going that way, and this line's never going to touch either of these planes. Okay? No. Line T is just the name of the line. So remember, one of the ways that we can name a line is by a lowercase scripted letter. It's not necessarily a point on the line, it's just the name of the line. So it's just a shorter way to name the line than by using 2 points. Okay? All right. You're going to put these in your notebook, okay, on page 8.